Alright, my apologies for not being able to finish up the example in the previous video, but here we go. So we found the common difference to be 4, and now we just need to use the general term of the arithmetic sequence formula. I'll plug in 17 and 3 for n, and the common difference, 4, we just found that out. So this 17 and that 3 comes from the third term being 17. And this common difference 4, well, we just found that out. So 17 is equal to a plus 2 times 4, 8. So a is equal to 17 minus 8, which is 9 if I'm not mistaken. And then now we want to plug in our a and d values, leave tn and n as variables. Simplify, and you should get tn is equal to 4n plus 5. The next example, if you're given two terms in a geometric sequence, you want to determine the common ratio r between the terms. If you are given consecutive terms, then really simple, divide the second term by the first term or the third term by the second term. Again, if you are given two terms that are separated, then this is going to require a little bit more work. R is going to equal, now subtract h minus c, because that will tell us the number of steps or skips in between those terms, and take that number and you're going to root the ratio of th divided by tc. So what I mean by that is, if you have, let's say, the second term and the fifth term and you want to find the common ratio r, then you're going to take the cube root, because that's how many skips there are between 2 and 5, 2, 3, 4, 5. And then you're going to divide t5 by t2. Once you have the common ratio, just use that and one of the given terms to determine the initial value a. So when you use the general formula, Tn equals AR to the power of n minus 1, you will have just found Tn and n, or sorry, you would have been given that information, and you would have just found your value of R. So you can just rearrange the equation to get A. And that equation is A equals Tn over R to the power of n minus 1. So in this example, the third term is 24, the seventh term is 3 over 2 in a geometric sequence. Determine the common ratio and A. So R is going to equal 7 minus 3, take that number, take the root of t7 divided by t3. So you want to take the fourth root of 3 over 2 divided by 24. Now 3 over 2 divided by 24, that is the same as 1 over 16. The fourth root of 1 over 16, half. So that's your common ratio R. And once you have that, you can find A by doing Tn over R to the power of n minus 1. So I'll take 24 for Tn, and R I just found is half. 3 minus 1. This 24 and this 3 comes from the fact that the third term is 24. And so you get 24 divided by a quarter, which equals 96 as your initial term. All right, last example, and this is tricky because you're given two terms in a general sequence that is not arithmetic or geometric, so you can't use the formulas at the top of the page. So instead, you just have to try to look for the pattern that gives you the term number based on, or sorry, the term Tn based on its term number n. So in this example from the first page, this is n equals 1, n equals 2. Oh, you know what? Sorry, I didn't like that, so I'm going to rewrite it. So n at the top, 1, 2, 3. Okay, first term, second term, third term. Try to look for the pattern that gives you the numbers in the numerator, that gives you the numbers in the denominator. The numerator follows the pattern of an arithmetic sequence, so I'm going to use Tn equals a plus n minus 1d, plug in my 3 for a, and plug in 2 for the common difference, and Tn equals 2n plus 1 for the numerator. The denominator are just whole numbers squared, 4, 9, 16. If you see the pattern, it's going to be n plus 1 squared, the term number plus 1 squared. And now put them together, numerator divided by denominator, and here is our general formula.